Hello, in this episode of Exploring Rust, I'm going to take a look at lifetimes in Rust. I've been through this several times already and it's been a disaster, but on the upside, every time I've gone through this stuff, my understanding of it has improved. So I'm hoping I can give you a reasonable explanation of lifetimes now. However, as always really, do take whatever I say with a pinch of salt because it's completely possible that I may have got the wrong end of the stick. This is just me learning Rust and trying to explain what I've learned, essentially. Oh yeah, I almost forgot to say, I'm also going to show you a program that I figured out I could make using Microsoft Copilot, but we'll save that for the end. First of all, let's talk about dangling references. I'm going to create a new project here, a new package. Let's just call it dangling. And if I go into there, I can then do cargo run. That looks fine. Now I'm going to open the main.rs that just generated. Here it is. I'll try to make that a bit bigger if I can remember my shortcut. There we go. So Rust, as far as I understand, Rust makes it impossible to create dangling references. Let's have a look at something that would be a dangling reference in another programming language. So one thing that I didn't realize was that I can do something like let x. I can just write that by itself, and later on I can set a value for x. So x is still an immutable variable. It's just that if you don't initialize it, Rust does let you initialize it later on. And after that, because I haven't specified mutable here, after that I won't be able to change it, but I can change it up to the point of initializing it. Let's just check that that works. Yeah, I've got warnings about X not being used. I think because those tend to get annoying in these videos, I'm going to write here hash exclamation mark square brackets allow unused to silence those unused variable warnings. I should really just put this in every time I start a video because I always end up doing this. Okay, so there's no problems with this, perhaps surprisingly. Now let's just get rid of that, and I want to have a restricted scope here. So I'm going to have a pair of braces and let y equal some number or whatever. And then I can say x equals a reference to y. And then, well, let's first of all just try printing x down here. So I'll have a pair of braces and can probably just put x directly in there. That's actually got to be print line exclamation mark, a semicolon on the end. And then if I run this, that's fine. So it prints 8. So of course the idea is that x is a reference to y. So if we change y later on, we're going to see that reflected in whatever value x refers to, because really there's only one integer variable here. X is just a reference to that same variable. But now if I move this down here, in C or C++, or I suppose in Java, I'm not sure if we could do something similar in Java. Maybe we could. This would actually create a dangling reference. That is, the language would let you do this, but the problem is the scope of y is restricted to these braces. So x would end up referring to a variable that no longer exists down here. So when we try to print it, we might get the value 8 or we might get some garbage. However, Rust doesn't let you do that. It tracks how long things live for, and when I try to compile this, it gives me an error. So it says binding y is declared here. That's y. Borrowed value does not live long enough. Y is dropped here while still borrowed, so y is dropped when we hit that closing brace. And then for the print it says, I'm not sure how to read this, borrow later used here, borrow later used here, maybe, I'm not really sure. But the point is that we are trying to use something that no longer exists because the thing it refers to was dropped. So this would be a dangling reference in another language. The point is Rust just doesn't let you do this. So Rust has to track carefully how long stuff actually exists for and prevent you doing stuff that would get you into trouble. This, however, just works perfectly fine. Now in C or C++, this will be a straightforward situation. these braces define scope. So they define the scope of y, which I declared inside the braces. And y would go out of scope here. So then we could still print x, but it wouldn't be valid. It would be garbage or whatever, potentially, if we tried to print it outside of the area where the thing it refers to, y, actually exists. In Rust, it seems there's a more subtle concept called a lifetime. And we have seen previously that references can be made to persist just until the last time that you use them. And if you don't use them, they can in effect expire. So as I understand it, in Rust, we could say that the lifetime of y ends when we hit this brace here. And the reference x, sure, it has a longer lifetime than y, I suppose, but the problem is the thing it refers to doesn't live long enough to actually print x outside of these brackets. Something like that. What I can tell you for sure is that apparently every reference in Rust has a lifetime. I'm not sure whether this means we should say that the lifetime of x actually ends at these brackets along with the thing it refers to or not. I'm not sure about that, but I don't think it really matters for our purposes here. What I want to do next is create a situation that could be problematic, but actually isn't. So I'm going to go to the console here and create a new package. Let's say cargo new. I'll call this lifetime 1 maybe. Can't really think what else to call it. So let's go into that and do cargo run. Okay, so there's hello world. Then I'm going to open that, which is in here. There we go. And actually, let's just copy this allow unused thing in case that gives me a headache again. So I'll put that there. Now I'm going to create a function that returns its parameter. So let's say fn. I'll call it maybe get text. And that can have a parameter called s, which is of type string reference. And we're just going to return s. So I need to say that the return type is also a reference to a string. So these are references to immutable strings of some sort. Then down here I could actually create an immutable string. Let's say let text equal hello. And I'll say let result equals get text, and I'll pass in text, and then we'll do print line exclamation mark. And in there I will print result. Let's see if this works. So I'll clear this and let's just do cargo format actually, just to make sure I've got everything in the right place. And I'll do cargo run. And you can see it says hello. So there's no problem with this. Now the thing is, I am returning a reference here. As I understand it, these are basically string slices, at least in the case where we make one of them refer to some hard-coded text. But I believe this would also work with other types like integers or whatever. This could potentially be a dangling reference. So if you return a reference from a function, as far as I can see, there's two possibilities basically. One possibility is that the reference will refer to something that was created inside the function, in which case it's not going to be valid anymore, because if you create something inside the function, I would think it's going to go out of scope when you hit this closing bracket. The other possibility, the valid possibility, is that the reference refers to one of the parameters, or something that's directly created from one of the parameters, I suppose. Maybe that's possible. And in that case, it could be valid. And in this case, it is valid. The reason this works is that the argument that was supplied is still valid down here. So we're returning a reference to this, and that's valid down here, and all that is perfectly fine. Now, Rust is actually tracking lifetime information here. So it's tracking the fact that this variable lives long enough to print a reference to it down here. It has to track it all the way through this function. And it can do that because this is a simple situation where we are passing a reference to a function and just returning that reference. We could explicitly specify lifetime information though. We could make this a template function. So lifetime parameters are not template, that's thinking of C++. Generic is the word I want, although it's basically the same concept. So we need generic information here. We can have a generic parameter, and the lifetime parameters start with apostrophes, and then we've got a variable name which is typically just a single lowercase letter, like A would do the trick. And then we can use that to annotate the references involved. So I could say here apostrophe A, probably have to put a space there, I'd imagine, and here we can put apostrophe A as well. Let's just check that that compiles before I start trying to explain something that might not work. Yeah, that's fine. So what's going on here? Well, okay, this is a generic type parameter, and we're not specifying it when we actually call the function, so it has to be inferred. And Rust is going to infer it by looking at this parameter here. So it's going to say that, okay, however long this parameter actually lives for, that's going to be information associated with apostrophe A. And that means that when we look at the return value here, the return value has the same lifetime as the argument that's applied to the function for this parameter. So by this means, it can connect the lifetime of the result to the lifetime of the parameter, and it can check that everything's okay. However, as we've seen in this simple situation, Rust can elide this lifetime information, and it can figure out that this is going to work anyway, even though you're not explicitly specifying how the lifetime of the returned reference is connected to the one and only parameter. That's my understanding of this, but we can take a look at a more complicated situation where you are forced to specify lifetime information, and that I'm just going to lift directly from the documentation because my understanding of Rust is probably not good enough to figure out an example for myself here. Well, maybe I could do it if I had a go, but I've been lazy and haven't tried. So let's create a new project. So I'm going to go to a terminal again and cd out of there, and I'll do cargo new lifetime 2, and we'll go into lifetime 2 now and do cargo run. So that should say hello world there, and then I can open the main.rs from that. Let's just maximize this terminal. I've got a shortcut in Visual Studio Code to switch between the terminal and the code, so I want to use that rather than minimizing and maximizing the terminal. Let's copy this and paste it up here again. Now I'm going to create a function that accepts 2 parameters. So let's create a function called longest, and this is directly from the documentation, and that's going to accept a string reference. I'll call it S1. That will be a reference to a string like that. I've temporarily forgotten how to write string references. Yeah, that's right. Yeah, it just looked odd to me for a second. And then S2, that's going to be a reference to a string as well. And this is going to return a reference to a string. And the function of this, or the purpose of this function, is going to be to return the string that's the longest. So I'm going to say if s1.len greater than s2.len, in that case we'll return s1. Otherwise, I'm going to return s2. And this actually doesn't compile. Let's go to a terminal and try to compile it. I'll do cargo format and cargo run. Yeah, so we got problems here, as you can see. It says missing lifetime specifier, and it actually tells you the exact syntax that would fix this problem. So it's complaining that this function's return type contains a borrowed value, in other words, a reference, but the signature does not say whether it's borrowed from S1 or S2. In fact, it could be either in this case. So let's try to fix this. In fact, before I do that, let's type something else that also doesn't work. So let's have the generic sort of brackets here, and I'll create 2 lifetime parameters, one for each of these actual parameters. Let's have apostrophe A, these always begin with apostrophes, and apostrophe B. And then I can say that the lifetime of parameter S1 is going to be apostrophe A. The lifetime of parameter S2, let's just get rid of this side pane, is going to be apostrophe B. And then the lifetime of the return value is going to be apostrophe A. So this isn't right, but let's see what happens. if I try to compile this, you can see that it says lifetime A is defined here, lifetime B is defined here. Those have to be inferred from the arguments that are passed to the function, I would assume. But what it complains about is S2. It says function was supposed to return data with lifetime apostrophe A, but it is returning data with lifetime apostrophe B. So this lifetime information it acts like part of the type of the thing that it applies to. And it's complaining here that I'm trying to return at this point something that has lifetime apostrophe B, but I've explicitly said that the return type has to have a lifetime of apostrophe A. So for that reason, this still doesn't compile. But I can fix this if I just get rid of B and I change this to A. So now it's all A. This now compiles. So let's clear the screen and run this. And it says hello world. So that function has compiled successfully. And we can actually use it. So I'll get rid of that. Let's have a couple of strings. So let text1 equal hello, and let text2 equal hi, and let text3 equal longest, text1, text2, and print ln exclamation mark, and in there we'll print text3. See how that goes. So when I run this program, it prints hello because that's the longer of the two strings. So this works just fine. So my understanding of what is going on here is as follows. This type information, this lifetime parameter, has to be inferred because we're not specifying it in any way when we actually call the function. It has to be inferred from the parameters. They both have the same lifetime. Now a longer lifetime can be coerced into a shorter lifetime, but not vice versa. So what will happen here is that if these two references that we have to supply for S1 and S2, if one of them has a shorter lifetime than the other, A will be inferred to be the shorter lifetime. So it's going to look at the lifetime of the arguments that are supplied, in my understanding anyway, and it will say whichever of the two is shortest, that is what A is going to represent. And then the return value here will have that same lifetime. And this enables Rust to check if this stuff is actually valid or not. So could we actually contrive a situation now where this doesn't work and where Rust's ability to check lifetimes, to check how long things hang around for, will actually make Rust not compile this program? Let's try that. So one thing worth mentioning here is that these immutable hard-coded strings, they all have a lifetime called static. So there are special lifetime names, not just A or B or whatever. And there's one called static, which means the thing lives for the lifetime of the program, basically. And these hard-coded strings have that static lifetime, apparently. So bearing that in mind, to get this to break, we'll have to make use of some other kind of string reference, not something that's just hard-coded like this. So I'll have text1 there. I think I can just leave that alone. And then let's delete text2 here, and we'll just have let text2. I'll have a pair of braces to restrict scope. Let's move this function call up into the braces like this. Now that's already wrong, isn't it? I've already done something wrong here. I have to think about this for a second. What do I need to do? Yeah, this has to exist outside of the braces, so I can, if I want to print it down here. So I actually want to put, let's make this text2. So that's defined there, so I can refer to it here. But I want to actually set it here. And then what do I want to pass in? I want to pass in some text3, let's call it, that I define in here. So here I'm going to say let text3, and I want to create some kind of string that can actually go out of scope. So I'm going to say equals string : from, like this. And I can call, after I've given it some text, let's put maybe hi, I can call .as str to convert that to the kind of a string that we actually need. this kind of a string. So let me check through this. So I've got text1 here, that should be fine. I've got let text2, which I'm printing down there. I'm initializing that text2 from the return value of the function, and I'm passing to the function one string that has a static lifetime, it's fine, and it's defined up here anyway, and another thing that doesn't have a static lifetime, it has a restricted lifetime because of these brackets. This string is going to go out of scope, it's going to get dropped when we hit this closing bracket here. So if Rust is doing its stuff, it should figure out that this does not live long enough to enable me to print the result down here. I don't really like the names that I've used. Let's call that result. This can then be result. This can be result, like that. And then I can call this text2. And that can be text2. That's a lot clearer, I think. Now, I think what's happening, what is going to happen, is that so every reference has a lifetime associated with it. It has lifetime information associated with it. It's just that you don't always see it because Rust elides it when possible. It will remove it, or at least not insist that you add it explicitly whenever it can do that. And the documentation actually says something about how earlier versions of Rust forced programmers to add lifetime information all the time. But since it was realized that there were many situations where they were just adding this lifetime information over and over again in patterns that were perfectly all right, the decision was made that you wouldn't always have to specify that information in situations where Rust can easily figure out that what's actually happening without explicit lifetime annotations. So this result has lifetime information associated with it. Where's it going to get it from? In my understanding, that's where it's getting it from. That says how long the reference result will actually live for. And that's going to depend on whichever the shortest lifetimes of these two references actually is, because that's what will be inferred for this type parameter here. That's what I think is going on. So this will now not work because Rust will figure out that this has a lifetime which is too short to print it down here. It's already expired when we hit this closing bracket because its lifetime information was composed partly from this thing up here. Let's try running it. Okay, so if I run it, you can see that it doesn't compile, it doesn't like this. On the other hand, if I were to change this to a actual hard-coded string, I think it will work. Let's comment that out, go back and run this. Now you see it says hello, it's returning the larger of the two strings. In fact, if I switch them around, it will still even work. Let's put hello down here and run that. So it still says hello, it's still selecting the larger of the two strings. Why? Because what we've got here is a reference to a string that has a lifetime of static. So if I were to type out the type of this, it would be reference to string for one thing. Let's actually try that. And you see that's totally fine. So that is the type of this, but all references have a lifetime, and the lifetime of this is actually static. So we could write static there, meaning it persists for the duration of the program. Let's get that in and try that. And you can see that Rust is still perfectly happy with that. So all of that stuff here, all of that was inferred. Well, this as well. So that whole thing there was just inferred as the type by the compiler. And this program works, but if we use something that's going to go out of scope to form the reference to the string slice, and we supply that as the argument, then this won't live long enough to print down here. So what the documentation says is that lifetimes most of the time are actually used to connect the lifetimes of input parameters in a function with the lifetime of a returned reference. So I would expect to be mostly using this lifetime annotation in cases where we're supplying references to a function, and then most importantly we are returning a reference from a function that depends on one or more of the supplied parameters, the supplied arguments to the function. So this is my understanding of it all anyway. Rust insists you put this stuff in because it can't automatically figure out otherwise that this whole thing would not work. It needs that information to figure out whether you can legitimately print result down here or not. So there's one other thing that I want to show you with lifetimes, which is that you can also use them on structs. You can use them in various places, actually, apparently. But let's create a cargo new lifetime 3 and go into lifetime 3 and do cargo run. And I'm just going to quickly demonstrate that you can use this with structs as well. So if I go to main.rs here, and if we create a struct, like let's call it star, so you can use references in structs, but if you use a reference in a struct, you have to supply lifetime information for the struct. So I could have here, for example, x, which is a reference to a I32 maybe, and this I don't think will compile. So if I now do, let's do cargo format, cargo run, you can see that it doesn't like that. And I don't have to do a whole lot to actually fix this. What I have to do is, after the name of the struct, supply a lifetime generic parameter, which can be inferred when we actually create the struct. And then I have to annotate this with that. So here I can put apostrophe A, and I'll put a space in there, otherwise it's just unreadable anyway. So let's try that. Yeah, and it's fine. I've got my dead code warning, which I love so much. Let's go and put a allow unused thing at the top, and then you can clearly see, I think, when I run it, that it's now totally fine. So of course you could have multiple of these. You could have comma apostrophe B. Let's just try it quickly. So I could have comma apostrophe B, and then there could be another parameter down here like Y, for example. That could have a different lifetime of B, and then if I run that, that's totally fine. But Rust needs to be able to figure out how long your references are going to live for, the references inside the struct. So you have to add this information basically. But what I don't really understand is what would you even do with this? So let's try to create an actual struct. Let's say let s equal, how do I do this? Star, and there I could put x is 8. No, it can't be 8, can it? We actually need something to make it refer to. Let's say let num equal 8 or 9, that'll do. And then here I can say x is a reference to num. So I should think that would work, wouldn't it? Let's try that. And here I need a semicolon. Let's clear it and do cargo run. Oh yeah, I called it start by mistake. I'll just do cargo format, and then we'll clear that and go back. That should be star. Let's try again. So yeah, that actually compiles. I don't really understand what this achieves, if I'm completely honest. What's it actually do? I mean, this information must be inferred when we create the struct, right? But couldn't it just infer it like directly from this parameter without that annotation? Apparently not, because we are forced to add it. Well, I'll leave that mystery for the future, but this is apparently what you have to do if you want to create a struct that has a reference in it, one or more references. Now to finish up, I just want to show you something I figured out I could do using artificial intelligence. So let's go back to the console here, and I'm going to cd and do cargo new lifetime. No, I won't. I'll call it starfield, because I'm going to create a starfield, and we'll go into there and cargo run. Okay, that's fine. Now I'm going to search for Microsoft Copilot, and if you haven't seen this before, you don't even have to register. You just go to the page. This may or may not still be working by the time you look at this video, if you look at it a long time into the future. But I'm sure in the future there's going to be things that are at least as good and hopefully also free. So this will generate code for me. I'm going to say something like create a Rust program that displays an animated star field using pixel level graphics API. That'll do. Let's try that. That sounds like a fun project. Fair enough. So I'm going to copy this, go back to my Rust program, and where's the actual one that I want? It's not this, it is the new one, which is right here. I'm going to paste that in there. Maybe I can make this smaller. All right. And wait, has it copied the whole thing here? Because that doesn't look complete at all. Look at that. Does that look complete to you? It doesn't to me. Let's go back to Copilot. I did get this working before though. Does it really end like that? No, it doesn't. Okay, I did something funny. Let's just copy it again and select it all and paste that in. Yeah, that looks better. Okay, right. I don't know what I did there. So now I'm going to try to... No, I'm not going to compile it because I need dependencies. So if I take a look at what Copilot has generated here, if I go down, we can see there are some dependencies listed. The weird thing is, every time I ask it to do this, it does it in a different way. I've asked it to do this 3 or 4 times, and it does it in a different way every time. So I don't know if this is going to work, but let's copy this and see what actually happens. So I need to put these dependencies in the cargo.toml, which is here. Let's paste those in there. If it doesn't work, I'm going to try to generate it again and we'll see what happens. So obviously there's some problems here. In fact, it says no versions found of winit input helper. So I'm not going to try to figure out what's gone wrong there. I'm just going to try to rephrase what I wrote to get something that almost works. Let's copy this again and go back there. Create a Rust program. I probably don't need to see. I don't need to say create, surely, do I? Could get rid of that actually. A Rust program that displays a starfield using pixel level graphics API. I won't say animated this time. 2 of the times that I've done this exact thing, once it created an animated starfield and the other time it wasn't animated. So I'll just try this, see what this does. All right, does this look simpler? Not sure yet. Maybe. I think it does. All right, still generating it. Here we go. Yeah, it's got an event loop in there, so maybe it will be animated. All right. No, look at this. It's got this winit input helper again. Why is it doing this? Because that doesn't work right. I don't want to use that thing. I'm going to try this again. Create a Rust program that displays a starfield using pixel level graphics API without using winit. Let's try that. All right. Yeah, okay, that one works because it previously created one using this mini FB thing and that actually worked. All right, let's try that. I'm going to copy that, go to my program, get rid of that, paste this in, go back to this, scroll down. Now we've just got 2 dependencies. That's much better. That's what I wanted it to create. Let's copy that and go to cargo.toml, paste this in. All right, so I'm using Visual Studio Code and the Rust plugin that you can install to do Rust in Visual Studio Code brings up these crosses, which is pretty nice because if I hover over them, I can select the latest versions of these dependencies and they change to ticks. I discovered this by accident. So I'll do that one as well. Wait, yeah, hover over it and go to that. Nice tick there. And now I'm going to try to compile this program. So I'm in the right place. Let's do cargo run. See what happens. So it's going to fetch the dependencies now, which takes like a few seconds, not very long. At least last time I did it. I suppose it depends on the speed of your internet connection. Let's see if I can keep talking long enough for this to actually finish. And what I found previously was that this had some errors in it, but they were only things that were deprecated. So we're getting, yeah, there you go. So we've actually got a starfield. That looks pretty nice. Wonder why it's getting slower like that. It's maybe just my computer speed or something. But as you can see, it's actually done what I asked it to. In fact, it's gone beyond what I asked it to because in the last time I don't think I mentioned animated. I said, what did I say? A Rust program that displays a starfield using pixel level graphics API. So I didn't even ask for it to be animated, but it's made it animated anyway. And if I hit the S key, I think, or just cross off the window, then it vanishes. So there are some problems here, but they're just warnings. One problem is use of deprecated method rand range gen range renamed to random range. So I've just got to rename gen range to random range if I want to get rid of that. Let's go to the code and take a look at where that's used. Gen range, let's change that to random range. All right, so I'll go back again and run it again. Yeah, there's still some of that in somewhere. I've got to carry on renaming. Let's just scroll down. So this gen range, that has to go. That's random range now. And if I scroll down, are there any more? I can't actually see any. So let's try again. So there's still some problems. Use of deprecated function thread range renamed to just range. So if I look for thread range and rename that, so that's there and there, I think that's probably it. Let's save that, clear this and run it again. So now you can see it's compiled with no warnings. So it's actually great. It's perfectly fine. And what's more, when we actually look at the code, it's not even that hard to understand. So if I take a look at this, so it's importing some stuff. That's fine. We've got some constants here. It's pretty obvious that that's the width of the screen, the height, the number of stars to draw. We've got a struct representing a single star, so it represents the position and the speed. Then we've got the implementation that supplies functions attached to the star, which I still don't really know whether I should call them methods or not, but never mind. Here we're creating a random number generator, and then we're setting x and y for the star struct. Yes, this is for creating a single struct, of course. We're setting those to random values, random floating point values between 0 and the width of the screen in this case. And we're doing the same for speed. And we've got an update function. And what does that do? That adds it looks like it adds a random value to x. If self is, oh yeah, I understand. Yeah, so it's adding the speed to the y coordinate so that the stars fall downwards. And then it's saying that if the y coordinate's gone off the bottom of the screen, because the y coordinates should, I guess, start at 0 at the top and they increase as you go down the screen, then we set y back to 0 and we set x to a random value up to the width of the screen. And then if we look down here, this is creating a window with the right width, height and a name starfield and some default options. And that's going to return something that's going to be either an error or OK. And if it returns OK, we're just going to unwrap and get the window handle out of that. Otherwise, we're going to do a panic and just terminate the program. Then we create buffers. So we're storing the pixels of the screen in a buffer here. You can see this is width times height. That's the number of pixels for the entire window. And then we've got stars. We were also creating a vector for that, a vector of stars. And then we've got an event loop. So while the window is open and the escape key hasn't been pressed, we're going to update each of the stars. We fill the whole buffer with zeros, which would make it black. And then we're saying for each of the stars, get the x and y coordinates. I guess these must be an integer type, I suppose. And we're also getting the index of the pixel in that whole pixel buffer. So the index of the pixel would be the y position of the star times width plus x. Because every time you go down to a lower row, you're adding on a whole width number of pixels. So that's why you end up with this formula. And then we just add x to actually go to the correct position horizontally, like from left to right. And then we're saying if the index is less than the length of the buffer, which, should that be necessary? I don't think it should be possible for a star to be off the screen, but maybe this is defensive programming. Maybe it's an unnecessary check. I'd have to spend more time looking at this to be sure. But it sets the pixel in this pixel buffer to the color white, and then it's just updating the window using that buffer information, using the pixel information from this buffer that it's created. All of this, I would say, I understand. I don't think there's anything in here that I would say I'm definitely don't know what it's doing. And it would be pretty easy to change this to make this output different colours, for example. So let's actually try that. Let's see if I can make multicoloured stars. So the colour information is stored in this 3-byte value here. So this byte here is going to be red, I think. That's going to be green, that's going to be blue. What we really want to do is split these up. So I could say, let's put this here. I think I could say let red, which I'll make that, I presume it could be I8, could it not? And what would I set a random red value to? Well, I need some kind of random number generator probably. Is there one in scope? I don't think there is. So I need to create something like this, I would assume. Let's create something like that down here where I can actually use it here. So probably if I put it down here, I could then access it in the right place. And then how do I actually create random integers? I could probably do this. So, oh yeah, I could probably just have actually done this. Now I could use range as well. All right, let's copy this and try that. So I'm going to set this to RNG, which I created here, dot random range, and I want to set it from 0, let's say, not that 0 is any use because that would be invisible, from OXFF. I don't know if that's inclusive of the end of the range or not, as I8. I'm not sure if that will work either. But let's actually try that. And if that works, then I can do blue and green and then assemble those into a actual complete color. So if I run this, okay, the literal OXFF does not fit into type I8. Yeah, because I need U8. I need unsigned. So I just need to write here U8, because only then can we fit the value 255 into it, or OXFF. Okay, I think that is building, but it says expected I8 found U8. What? Oh, I know. That's also got to be U8. Let's try that. It's got to be unsigned. Okay, so that compiles. Have I got any warnings here? There should just only be an unused variable warning at the moment. Let's just try that. Yeah, so unused variable red. Everything else is fine, I think. So I'm going to duplicate that because I want to have green and blue. And then I'm going to say let color, which is going to be of type... Is there an I24? Probably isn't. Would I want it if there was one? I probably want U24. I'm going to try this. I don't think this will work. But I need to assemble this from these 3 different colors. And I should be able to do this using bit shifting, right? So I should be able to say that is equal to... now I've just realized I probably can't bit shift these because they're too small. I'm actually just going to change these to I32. I don't think I need them to be this small at this stage. Let's try that, and here, because then I can do bit shifting on them. I can do red, shift that into position by moving it across 2 bytes, and then add that to green, shifted across 8. So I'm just going on, these are the bit shifting operators from C, C++. I think they're in Java as well, aren't they? I think so. And then add on the blue value, and I think that would assemble me a random color, which I could then use down here. Let's just try that. So if I run that, have I used a U somewhere? Yeah, I meant probably... it just doesn't like U24. That's not going to exist. I was very optimistic there. Let's use I32, which is big enough, and try that. Buffer expected U32 found I32. All right, let's make it U32 and try that. Expected U32 found I32. You can convert an I32 to a U32 and panic if the converted value doesn't fit. All right, I'm happy to try that. So I don't really know what that code does, but let's try that whole thing. So could I not just make that an I32 and make this a U? That's not going to convert it to U32 though, is it? I mean, it seems to work. Have I got any warnings? I've just got an extra semicolon. Let's try that. I'm going to clear it and run it. There you go, no warnings. Okay, and I'm going to now peer closely at this. Yeah, it's really difficult to see, but what's happening is the stars are actually twinkling. They're twinkling lots of different colours. So I think it would be better if I fixed the colour of a star when I created it, instead of changing it every time I actually draw the stars. That was a bit stupid. But anyway, I didn't think of that. But this all does work though. I don't know what that's actually doing, except that it's converting a U32 to an I32, is it? No, it's converting an I32 to a U32. I don't know how that works, but anyway, it does work. And that's now the only thing that I don't really understand in the entire program, I think. But I just wanted to show you this because I was just really impressed by, after what I've made, like, this is my 24th video, I think. And admittedly with something of a background in various programming languages like C and C++, I'm able to understand all of this perfectly well. In fact, it's not even necessary to use lifetimes in this program. They don't occur anywhere as far as I can see, not explicitly. And the whole business with references, the whole complication of not being able to have two references to the same thing, all that sort of thing, none of that really seems to enter into the difficulty inherent in this program. So I think I could, if I was familiar with this graphics API, so if I just looked up what functions to call, I'd be pretty optimistic about being able to write this from scratch, which I might try at some point. Anyway, that's more than enough for this video. So until next time, happy coding.